So now we are just moving towards our Dirac equation. Okay. And last class में हम लोगों ने थोड़ा डिस्कस किया था what is the actual idea behind the Dirac equation. So it's a very interesting way to approach any any complicated problem. So what we have h square, and this h square is basically p square c square plus m naught square c4. This is my classical Hamiltonian. And what Dirac suggests that we can write this whole thing in term of c alpha dot p, alpha can be some vector, plus beta m naught c square and whole square. So what will happen? So now if h square is equivalent to this one, then this is complete information of h, isn't it? So what I can write my h as c alpha dot p plus beta m naught c square. Now the whole idea is that what will be your value of, and what will be the composition, configuration of alpha as well as beta. These two things is most important thing that we have to analyze and we have to just figure it out. So now let's try to go for this particular derivation, and this is a really very wonderful derivation, and you will surprise that the symmetry what you have seen into the Pauli exclusion principle will come into picture automatically. Now let's try to go for this one. So I can write this alpha as my vector. This alpha vector is nothing but alpha xi, alpha yj plus alpha zk. And this p is, obviously we know this p is nothing but pxi plus pyj plus pzk. And by the way, what is this p square? This is nothing but px square plus py square plus pz square, isn't it?
Yes, sir.
So this is just my p square. Now what we are going to do, we will just try to equate these two equations. And when we are going to equate these two equations, we will just try to keep all quantum mechanical technique in our mind. So let's try to go for this. Can I write this whole thing as p square c square m naught square c4 must be equal to c alpha x into px plus alpha y into py plus alpha z into pz and plus beta mc square, and we can just go for multiplication of the same thing. So I am writing something like this, alpha x px, because this is just like an operator. So when it is operator, you cannot write a square plus b square plus 2ab. Are you getting my point? When it is operator, then ab and ba have entirely different value, and it have entirely different property. So what we are trying to do, alpha x px and alpha y py, alpha z pz plus beta mc square. Now, and this term is nothing but px square plus py square plus pz square. So I can write this whole term as px square plus py square plus pz square. And what we are going to do, we will just try to compare the coefficient of px square c square on both sides, py square c square on both sides, and these are the diagonal coefficient px square and px square, and there is also coefficient alpha x alpha y alpha x, that will be coefficient of px and py, because px and py is going to commute to each other. So there is not any harm that we can write px into py is equal to py into px. Are you people going to understand what is the logic behind that? Everyone?
Yes, sir.
Okay. So what will happen? So now let's try to compare the coefficient of px square on both sides. So what is the coefficient? Alpha x square is equal to what? Identity. Yes. px square, alpha x square, px square, c square. So this is c square, and that means alpha x square is equal to what? Identity. Similarly, alpha y square is equal to also identity. Alpha z square is equal to also identity. Now, let's try to go for beta square into, and there is m naught square, so you can just go for rest mass, so there is not any problem. So if you are going to compare the coefficient of m naught square c4 on both sides, then what you will get? बताइए. Beta square is equal to what? Identity. Yes. So
Yes,
this
sir.
is our diagonal part. Now let's try to go for a mixed part. So there will be alpha x, alpha y, and alpha y, alpha x. So we are just going to compare the coefficient of px and py. Are you people happy? So what will be that coefficient into both sides? We have alpha x, alpha y plus alpha y, alpha x. That value is equal to 0, isn't it?
Yes, sir.
And here's you have alpha y, alpha z plus alpha z, alpha y must be equal to 0. And here we have alpha x, alpha z plus alpha z, alpha x is equal to also 0. And the last but not the least, what you have? You have alpha x beta plus beta alpha x. That value is also 0. Alpha y beta plus beta alpha y, that value is 0. Alpha z beta plus beta alpha z is equal to 0. So now look at this, should be the property of alpha x, alpha y, and alpha z. Now here the actual intuition come into picture. So what we have to do, we have to find the alpha x, alpha y, alpha z such that it should follow these property, as well as beta, it should follow these property. Are you getting my point?
Yes,
ऐसा
sir.
कौन सा वेल सा अरेंजमेंट होगा जो कि इस तरह के प्रॉपर्टी को वो फॉलो करे? Then we have already have intuition of what? Pauli spin matrices. Remember?
Yes, sir.
The Pauli, the component of Pauli spin matrix is sigma x square is equal to identity, sigma y square is equal to identity, sigma z square is equal to identity, and Pauli spin matrices are just going to make to anti-commute to each other. So this is all this particular thing. And now from here we can have alpha as a vector. We can represent this will be 0, sigma, sigma 0, and beta is nothing but identity vector 0, 0 minus I. And this is representation in 2 cross 2 matrix. We can represent this whole thing in 4 cross 4 matrix. So what will be your alpha x? So if you have all this information for the Pauli spin matrix, then your alpha x can be represented as, यहाँ तक क्लियर है ना?
हाँ सर.
सर
Okay.
अल्फा 0 I 0
Sorry?
ऐसा आएगा ना? एक हमने आइडेंटिटी मैट्रिक्स के फॉर्म में लिखा और दूसरा
क्या है?
सब
Where is problem?
अल्फा बार जो हमने लिखा है ना ऊपर
This
सब
one?
मैट्रिक्स नहीं ऊपर अल्फा बार लिखा है.
अल्फा वेक्टर है भाई, दिस इज वेक्टर.
सॉरी हाँ अल्फा वेक्टर जो लिखा है.
हाँ क्या इसमें क्या प्रॉब्लम है?
वहाँ 0 I जीरो
हाँ?
ऐसा नहीं आएगा क्या?
क्या बोल रहे हो?
जीरो आई जीरो ऐसा नहीं आएगा क्या आइडेंटिटी?
ये
हाँ उसमें सर
आई एम नॉट गेटिंग व्हाट यू वांट टू लर्न हियर.
सर अल्फा आपने पाउली स्पिन मैट्रिसेस के रूप में लिखा है और
हाँ
बीटा आपने आइडेंटिटी मैट्रिक्स के रूप में लिखा है।
हाँ, फिर
तो सर उनका कहना है कि हम अल्फा को पाउली स्पिन मैट्रिसेस के रूप में लिख सकते हैं।
अल्फा को तो पॉलीस्पिन मैट्रिसेस के टर्म में लिखा है, और क्या चाहिए?
मतलब बीटा से रिप्लेस करके इसको आइडेंटिटी मैट्रिक्स की टर्म में लिख सकते हैं सर।
भाई जो हमारा पर्पस पूरा करेगा हम तो वो लिखेंगे ना.
हाँ सर लिख सकते हैं, पूछ रही हूँ मैं सिर्फ.
आर यू गेटिंग माई पॉइंट?
Yes.
This is not an arbitrary thing. You have to
हाँ.
fulfill all this notation. Are you getting my point?
Okay.
And for here you have to go into group theory. ऐसे थोड़ी डिराक ने लिख दिया होगा. Are you getting my point?
Yes sir.
So if you will go for a complete group, अगर complete group कैसे बनेगा? Then sigma x, sigma y, sigma z, as well as identity matrix, as well as minus I matrix, can we make a complete group?
Okay sir.
Okay, just here just try to believe it. Okay, and this will fulfill all the, you have to just counter check whether they are fulfilling this thing or not. Are you getting my point? You are not getting this thing.
I'm getting it. For
What I am
after-
saying is that this and this is fulfilling this thing. You have to just counter check. That's it.
Yes sir.
You cannot think like Dirac कि Dirac ने कैसे इसको लिखा होगा. Okay,
Clear.
just accept whatever he has given. Okay, this is very intuitive. This is very intuitive. Don't think that you and I can think like that. The beautiful part is that we have to just accept it, and more what we can do, we can just check it. Are you getting my point? So here we can have alpha x, and alpha x is basically 0 0 0 0. This can be written as a 4 cross 4 matrix, and there is sigma x 0 0 sigma x 0 0 0 0 0. Are you getting my point? Sorry, ऐसे नहीं, मैं क्या गड़बड़ कर दिया हूं? Sorry. This value is equal to what? 1 1. What is polyspin matrix? That is 1 and 1. Are you getting my point?
Yes sir.
This is your alpha x. What will be your alpha y? 0 0 0 0 0 minus I 0 0 minus I 0 0 0 0 0. Now you can check whether these things are just fulfilling all this property of alpha or not, this matrix. Now what will be your alpha z? That value is 0 0 0 0. That value is what? 1 0 0 minus 1, and that value is 1 0 0 minus 1 0 0 0 0. And what is your beta? Your beta can be written as something like 1 0 0 1 0 0 0 0 0 0 0 0 minus 1 0 0 minus 1. So this alpha x, alpha y, alpha z are basically these are your alpha x and alpha y, alpha z, which will satisfy this equation. Are you getting my point? So this thing is going to satisfy this equation. This is very interesting. Are you okay?
Yes sir.
So now you have this definition of alpha x, alpha y, as well as beta. Now you can use it as a fact that when you have Hamiltonian like this, when you have and this is what classical Hamiltonian. When you have Hamiltonian like this, and this is classical Hamiltonian, then what will happen? You can replace this Hamiltonian, and Suppose your classical Hamiltonian is something like this. This is Hamiltonian square. Suppose your classical Hamiltonian is something p square c square plus m naught square c4 root under. Suppose this is your classical Hamiltonian. You can replace this classical Hamiltonian with the help of Dirac Hamiltonian, and that value is equal to beta m naught c square. Are you getting my point? समझ रहे हो क्या कह रहा है यहां पर? है ना? So you can just replace this thing. This can be replaced by this. Okay? This is your classical Hamiltonian. You can replace it by Schrodinger Hamiltonian also. Schrodinger Hamiltonian के लिए P को क्या लिखोगे? Minus h cut square d square upon dx square. Are you getting my point?
Yes, sir.
And
Yes, sir.
similarly, if you want to replace it with the Dirac Hamiltonian, you have to write this one, and where your alpha is defined as alpha x, alpha y, alpha z is defined like this, and beta is defined like this. Clear hai ye? And now from here you can again get the probability density as well as probability current density. Okay, so let's try to get the probability density and probability current density for the Dirac Hamiltonian. इसके लिए हम ये बात करने की कोशिश करते हैं. So obviously, what is your Dirac Hamiltonian? The Dirac Hamiltonian is C alpha dot P plus beta m naught c square. So if we are going to write this thing as an operator, what is this h? This h is I h cut. You can operate on some psi d psi upon dt. C alpha, and what will be this value of P? क्या होगा value of P? Minus IH cut del, isn't it?
Yes, sir.
Del psi plus beta m naught c square psi. You can write this. You can write kit also. There is not any problem. Okay. Now psi पर कर रहे हो तो psi की तरह ही रखते हैं, because psi star के टर्म में लिखेंगे तो ज्यादा बेटर समझ में आएगा. Okay. Kit के लिए फिर now what we are going to do? Again we will multiply it with what? Psi star.
Yes.
है ना? किससे मल्टीप्लाई करेंगे? Psi star से. So you will have psi star IH cut d psi upon dt must be equal to, C is constant, so I will just go for psi star C, and I will just write minus IH cut also. Minus IH cut C, that is psi star alpha dot del psi, and here you can write psi star beta m naught c square psi. लिख सकते हैं ना? Now we can write this Dirac Hamiltonian on psi star also. यही तो तरीका होता है. Yes?
Yes, sir.
So when you will write for the psi star, what is going to change? इसमें क्या change होगा? क्या same रहेगा या change होगा? That will be minus IH cut.
Yes, sir.
Okay? And that value is d psi star upon dt. And that value is equal to, minus से क्या हो जाएगा? This value is equal to what? Plus.
Plus IH.
So that will be plus IH cut, and this value is plus. Okay? IH cut delta psi star plus beta m naught c square psi star. Now what we are going to do? We will just multiply then psi on both sides.
Yes,
दोनों तरफ किससे multiply करेंगे? Psi के साथ multiply करेंगे. So when we are going to multiply with psi basically, and we can take minus IH cut d psi star upon dt, plus you have I h cut c psi alpha dot del psi star, plus you have psi beta m naught c square psi star. Okay, and now you can क्या करोगे इसके बाद क्या करोगे सब्ट्रैक्ट करोगे ताकि ये वाला पार्ट क्या हो जाए गायब हो जाए
कैंसिल हो जाए
है ना so you can just subtract it and finally you can write the whole thing into this form d rho upon dt plus del dot j must be equal to 0 and you will surprise that your rho is equal to exactly as Schrodinger density. This is your rho. Are you getting my point?
Yes, sir.
है ना और आप easily देखोगे that your current density J is actually given by that C psi star alpha psi. Alpha is vector quantity, so this J can be represented as a vector or tensor or matrices के रूप में लिख सकते because this is what 4 cross 4 matrix, isn't it?
Yes, sir.
Now you can have this particular value of J. So you can easily get what is your current density and what is your probability density. So this is your current density for the Dirac. This is your probability density for the Dirac equation. Are people happy?
Yes, sir.
yes
Okay. So let's try to go for a very fundamental problem in this case. And then we will, in the next class, we will just go for a next level where we will just try to go for the interaction of charged particle in a magnetic field. Okay? वो हम लोग देखने की कोशिश करेंगे. Hope आप लोगों का वेक्टर पोटेंशियल वगैरह हो गया ना फाइनली आज?
Yes, sir.
Okay,
Yes, sir.
that's good. That's a great sign. ठीक है, इसको हटाए.
Yes, sir.
Okay.
Yes.
ये सारा एग्जाम में डायरेक्ट आ सकता है ना, तो आप ध्यान रखोगे. Okay. And you can revise with your booklet. It's a very nice thing. Okay. बहुत अच्छे से दिया हुआ है बुकलेट में एक एक चीज. I think we have already discussed Ehrenfest theorem. Discuss किया है ना? dA upon dt is equal to 1 upon IH cat
Hamiltonian.
AH. Remember this thing?
Yes,
yes
sir.
sir.
है ना? So del A upon del T. Okay, great. So let's try to go for a free particle. And let's try to go for the directly Dirac free particle. And let's try to calculate the velocity and acceleration of Dirac free particle. What will be velocity and what will be acceleration of Dirac free particle? So let's try to go for. What is velocity? This is nothing but dx upon dt. This is velocity, isn't it? So you can just go for 1 upon IH cat and we will go for expectation value. And what is A? X, H, what is X? H for the Dirac Hamiltonian? C alpha dot P plus beta m naught C square. And obviously this part is 0 because this is not a explicit function of time. You can just go for average value. Okay. Now X will going to commute with beta m naught C square because it is diagonal matrix, isn't it?
Yes, sir. Yes.
Okay. So here X is going to commute only the PX, isn't it?
Yes. Yes.
क्योंकि X के साथ आपका क्या आइडेंटिटी मैट्रिक्स लगा हुआ और X is only going to commute with what? PX, and it is just going to, sorry, X is not going to commute with PX and it is going to commute with all other fraction, all other part of P.
Yes sir.
Yes.
Yes.
So effectively, what we will get? This is my Vx. So effectively, what I will get? I will get 1 upon IH cat and X C alpha X Px. All other term is going to 0, isn't it?
Yes, sir.
Okay. So if all other term is going to 0, so this will be 1 upon IH cat and this is equivalent to X Px and you can write alpha X here Obviously, X is going to commute with alpha X because it has some identity type of matrix, and this will be, so you X and alpha X is going to commute to each other, and you can write C also. What is X and PX?
IH cut.
IH cut. So what will be value? The value is equal to alpha X C is the velocity of your free particle in X direction. So similarly, we can get Vy. What will be Vy? Alpha YC. What will be Vz? Alpha Z C. Isn't it? So what is my velocity vector? My velocity vector is equal to alpha X C in I cap, alpha Y C in J cap, plus alpha Z C in K cap. And so you have C alpha vector, and this will be your velocity vector. Isn't it?
Yes, sir.
And now you can check what will be your current density. What is your current density? Psi star C alpha psi. And you can, and psi star psi is nothing but what? Probability density.
Rho.
Yes. So this will be C into alpha, and that will be mod psi square. And what is this particular thing? This particular thing, I am just talking about J vector. This is nothing but the velocity. And what is this thing? Rho. So you are just fulfilling the all this condition. Yes?
Yes, sir. Yes, sir.
You have, and this is your velocity as your vector. Now, in general, what is the acceleration for the free particle?
0.
0. But we will just try to figure it out. What will be acceleration for Dirac particle? इसको जरा सा हम देखने की Dirac free particle को देखने की कोशिश करते हैं. Are you getting my point?
Yes, sir.
Let's try to figure it out. अभी कैलकुलेट करूं या फिर आप इसे कैलकुलेट करोगे, कल इसे कैलकुलेट करूं, because it's already 9:15.
ट्राई करेंगे सर.
हाँ?
सर ट्राई करेंगे एक बार सर.
चलो. So how you will try it? Don't worry, हो जाएगा. So how you will try it? Very simple.
dvx by dt.
Very good. dvx by dt. So अब आप कैसे ट्राई करोगे? So ax पहले निकाल लेंगे. What is ax? That is dvx upon dt. Now you have to go for what? Vx into h. यही होगा ना?
Yes, sir.
Okay.
By
And what is your Vx? C alpha x.
Alpha X.
And what is your h? C alpha x px plus alpha y py plus alpha z pz plus beta m naught c square. Yes? यही होगा ना? Now alpha x and alpha x is going to commute. Are you getting my point?
Yes, sir.
Alpha x and alpha x is just going to commute. So effectively, which one is going to survive? Effectively, you have
By Z.
C alpha x alpha y py plus C alpha x alpha z pz plus C alpha x beta m naught c square. And here what is going to, यहाँ पर क्या क्या survive करेगा? Then you have alpha x and py is going to commute. There is not any problem. So you have C alpha x alpha y plus C alpha x alpha z, and py is also there. And py is also there. Alpha x alpha z and pz plus C. What is this value? Alpha x beta into m naught c square. Now can you please tell me what will be alpha x alpha y, commutator of alpha y, alpha x alpha y?
IH cut alpha Z. IH cut alpha Z.
क्या हो जाएगा ये?
Sir 2 alpha Z.
That will be 2 alpha z, 2
Yes,
alpha
yes.
z होगा.
Yes, sir. 2 alpha Z.
कैसे निकाल रहे हो 2 alpha z? look at here, alpha x alpha y minus alpha y alpha x, यही तो निकालना है आपको. Yes, this is your commutator alpha x alpha y, and now we have alpha x alpha y plus alpha y alpha x is equal to 0. So I can write alpha y alpha x is equal to minus alpha x alpha y. लिख सकते हैं ना?
Yes, sir.
So this value can be written as 2 times alpha x alpha y. लिख सकते हैं इसे?
Yes, sir.
So here you can write c 2 times alpha x alpha y py plus c 2 times alpha x alpha z pz plus this value will be also written as c 2 times alpha x beta m naught c square. Are you getting my point?
Yes, sir.
अब यहां से सारे में से हम क्या निकाल सकते हैं? 2 टाइम अल्फा एक्स को निकाल सकते हो बाहर?
Yes, sir.
निकल सकता है ना? So you can
Yes, sir.
take 2 times alpha x into c outside, and inside you have alpha y py, and you can put c also here, so there is not any problem. C alpha y py plus c alpha z pz plus क्या हो सकता है यहां पर? c बीटा m नॉट c स्क्वायर. लिख सकते हैं ना?
Yes, sir.
यस. नाउ अब इस पूरे को आप हैमिल्टोनियन के टर्म में लिख सकते हो.
Yes, sir.
यार एक सी और कहीं मैं छोड़ रहा हूं ना. आई थिंक आई एम जस्ट नेग्लेक्टिंग वन सी. यहां पर सी होगा ना? आर यू गेटिंग दिस थिंग? दिस सी इज ऑल्सो देयर ना? This C is also there. This C is also there. This C is also there. So there is some C here. So this you will take C into C, C into C, and then you have one particular C. So there is not any C. So there is this C. So what we can take? We can take one C outside. So this C is not there. I think clear है ना आपको?
हाँ, sir.
So this will be C square, and here is C. Clear है ये?
Yes, sir.
मैंने जो अभी चेंज किया वो देख रहा हो ना? मैंने ये सी छोड़ दिया था सबके साथ. आर गेटिंग माय पॉइंट?
यस सर.
नाउ अब इसे आप हैमिल्टोनियन के टर्म में लिख सकते हो. यस या नो? दिस होल टर्म यू कैन राइट इन फॉर्म ऑफ हैमिल्टोनियन. कैसे लिख सकते हैं बताइए? 2 टाइम अल्फा एक्स सी यू कैन ऐड विथ सी अल्फा एक्स पी एक्स and you can subtract with c alpha x px. कर सकते हैं इसे?
Yes, sir.
yes या no? है ना? So you can write c alpha y py plus c alpha z pz and minus c alpha x px. और पहले इसको बीटा वाला पार्ट लिख लो. प्लस बीटा m नॉट c स्क्वायर minus c alpha x px. So what is this particular thing? This particular thing is what? Hamiltonian. Yes?
Yes, sir.
ठीक है ना? So last वाला जो पार्ट है वो आपको दिखाई देना चाहिए. Are you agreed with this? So this part is nothing but what? Your Hamiltonian. And finally, you can write this whole thing as 2 times alpha x c h minus c alpha x px. लिख सकते हैं इसे?
Yes, sir.
यस सर.
है ना? And now alpha will be go with this. So you have 2c alpha x h minus c. This is what? Alpha square is what? 1.
Yes, sir.
So alpha x square px. So this value is equal to your ax. सही लिखा है? And 1 upon I h cut is also there. 1 upon I h cut is also there. 1 upon I h cut हर एक जगह पर रहेगा. So finally, you can just go for this all thing with what? 1 upon I h cut. सारे के साथ आप ले जाओगे. That will be 1 upon I h cut and 1 upon I h cut is always there. Clear है ये? And by I h cut by I h cut. So 2c upon I h cut is there. So this is alpha x square is equal to what? Identity. So there is not any problem. So you have ax is equal to 2c upon I h cut alpha x h minus c px. Yes. So this is your ax. So similarly, you can go for what? Ay, and similarly, you can go for what? Az. So what will be your a? A क्या हो जाएगा? बताइए. 2c upon I h cut, and this value is equal to alpha h minus c, and this value is what? P. That is your acceleration for Dirac Hamiltonian. चलो मैंने कर ही दिया पूरा. आप एक बार रीचेक कर लेना. ठीक है?
Yes, sir.
है ना? Just try to recheck it. So this is your acceleration. So if you have Dirac Hamiltonian, then you can use this Ehrenfest theorem और कोई भी physical quantity के बारे में बात कर सकते हो. Isn't it?
Yes, sir. Sir, एक
So-
doubt है, sir.
हाँ बताओ.
सर अगर हमारा पार्टिकल फ्री है तो ये एक्सप्रेशन आ कहाँ से रहा है सर?
ये पार्टिकल फ्री है तो इसमें एक्सेलरेशन आ कहां से रहा है? ऑब्वियसली यहां पर कुछ इंटरनल सिमेट्री है. आर यू गेटिंग माय पॉइंट?
जी सर.
And this internal symmetry is something synonymous with the spin.
Yes, sir.
Okay, so there
Yes,
is due to this particular fact. देखो इसको हम क्लासिकली नहीं एज्यूम समझ सकते हैं, बट अगर आप बहुत ही मोरलेस क्लासिकली इसको आप समझने की कोशिश करो, तो ये जो इंटरनल सिमेट्री इज एनालॉगस टू व्हाट? योर स्पिन ऑफ द पार्टिकल, है ना? ये क्या है?
Yes, sir.
सिग्मा एक्स, सिग्मा वाई, सिग्मा जेड इज जस्ट टेलिंग यू सम इंटरनल रोटेशन ऑफ अ पार्टिकल अबाउट इट्स ओन एक्सिस,
Yes, sir.
है ना? So
Yes, sir.
this can bring you some acceleration to your system, even if it is free.
Okay. Yes, sir. Yes, sir.
Are you getting my point?
Yes, sir.
है ना? तो most probably that may be the answer. Okay,
Yes, sir.
but yes, you cannot arbitrarily say that okay, if it is free particle, then that is not any acceleration. There is acceleration because Dirac particle have this type of nature. And
Yes, sir.
and you can also see that if you are going into the relativistic range,
Yes, sir.
if you are going into the relativistic range, then dp upon dt is equal to constant, isn't it?
हाँ sir.
But it doesn't mean that m is not going to change, है ना? वहां पर
Yes,
आप
sir.
मोमेंटम में जस्ट कांस्टेंट कर रहे हो, तो यहाँ पर m की वैल्यू चेंज हो रही है v के साथ एवरी टाइम.
Yes,
Okay.
sir. Yes, sir.
So
Yes, sir.
this is all about relativistic thing. So there are n number of things that can be incorporated to this particular acceleration,
जी sir.
है ना?
हाँ sir.
तो हम वो क्लासिकल जो बात करते हैं, m v dv upon dt is equal to 0, where we are just assuming that mass of particle is what? Constant.
Constant sir.
तो आप उस मोमेंटम की बात कर रहे हो. Are you getting here? But here is everything is going to change because my Hamiltonian is something like p square c square m naught square c4, and where this p is associated with what? Relativistic mass, isn't it?
Yes sir.
And as well as internal symmetry is also there. उसके बारे में भी आप assume कर सकते हो. So what is exactly what is the reason? It is very difficult to say at this point of time. But yes, there is acceleration even your particle is free.
जी sir.
Actually, we are not talking about the kinetic energy.
Okay sir.
We are not talking about the kinetic energy. We are talking about the total energy. समझ रहे हो?
हाँ sir.
है ना? So
मतलब mass
total
की energy भी included.
exactly. So यहाँ पर आप constant momentum is equivalent to constant kinetic energy.
Yes, sir.
So why we are taking this particular thing? But here constant momentum is not talking about, this is not a kinetic energy. This is something else. इसके अंदर कुछ ना कुछ potential rest mass के रूप में है या mass के रूप में है. Are you getting my point?
Yes, sir.
तो वो चेंज होने के कारण भी एक्सेलरेशन आ सकता है. ठीक है.
Yes, sir.
But I will try to figure it out what will be the actual thing. But more or less these can be the thing. Okay.
Okay, sir.
Okay. चलो. Thank you.
Okay, sir. Thank you, sir.
Thank you,
Okay,
sir.
sir.